Welcome to Adding Years, your roadmap to longevity, a playbook for living healthier and longer. I'm Josie. Along with being a certified personal trainer and longevity enthusiast, I am also a data and AI executive with 4 master's degrees, including one in AI from Johns Hopkins. In each episode, I'll share simple technology and AI-backed strategies with practical steps that you can use to build your own longevity roadmap. I'm not a doctor or medical professional, so be sure to check with your physician before trying anything we discuss on the show. Today, I want to talk about a tool that's already shaping how we research, understand, and make decisions about our health: artificial intelligence. If you've scrolled social media lately, you know AI is everywhere. It's powering headlines, sparking debates, and generating some very interesting images. The hype is real, and it is also very overwhelming. Do you need ChatGPT, Claude, Gemini? Should you trust what they say about your health? Or are you just setting yourself up for hallucinated nonsense? This episode is the start of a 2-part deep dive into how AI can transform your longevity journey. Part 1 is all about research, how to use AI as a powerful partner to navigate studies, cut through hype, and build evidence-based knowledge faster. Part 2 will take it further, showing you how to create your own personalized AI longevity agent, a system that analyzes your wearable data, lab results, and lifestyle logs, and helps you design and refine protocols that actually work for you. Think of this as a roadmap. First, we'll master the skill of asking smarter questions and verifying information. Then we'll turn that knowledge into a living data-driven feedback loop to help guide your health decisions. Let me tell you a quick story. Early last year, I spent weeks buried in PubMed trying to make sense of dozens of NAD studies. They contradicted each other, used different populations, doses, and timelines, and created about 1 million different interpretations. This year, I asked a well-tuned AI model to summarize the evidence, the strengths, the weaknesses, and the gaps. Within minutes, I had a structured overview. It didn't replace the deep reading, but it got me from being lost in the weeds to a clear starting point in record time. Longevity is complex. It's genetics, hormones, diet, peptides, sleep, exercise, inflammation, cognition, and more. New studies drop daily, and experts disagree. It's hard science mixed with N-of-1 experiments. No one can read it all, but AI can help us digest this mountain of information and find the patterns hidden in the noise. To be crystal clear, AI is not a doctor. It's not omniscient, and it's certainly not infallible. But when you learn to use it responsibly, it becomes one of the most powerful tools in your longevity toolkit. A research partner that never gets tired, doesn't have language limitations, and always has time to cross-check 5 more sources. To start, here's a little context about myself. I've been working directly in the data and AI space for years and also have a master's in AI. So when I say I live and breathe technology, I really do. But even with all my technical experience, I have and am still learning that using AI for personal health and longevity research requires a totally different mindset. So let's start by unpacking what we're really talking about here. When most people hear AI, they picture a broad range of things from robots to digital assistants. But what we're really discussing here today are large language models, or LLMs. An LLM is an AI system trained on an incredible amount of text data from books, articles, websites, and transcripts to learn how language works. The model doesn't think like a human. Instead, it predicts the most statistically likely next word based on patterns it's absorbed. Sounds simple, but when we scale it across trillions of words, it starts to look like reasoning and explanation. Here's where it gets powerful for longevity research. Every day brings new papers, updated trial registries, preprints, expert interviews, and even large anecdotal threads. If you try to manually read even a fraction of this, you'd still fall behind. And AI can take that ocean of information and filter it into something structured, digestible, and tailored to your exact question. For example, say I'm curious about GLP-1 drugs like semaglutide, but specifically in non-diabetic populations interested in healthy aging. If I search PubMed, I get dozens of papers, some in mice, some in obese adults, some in diabetics, different endpoints, doses, and outcome measures. It's quite overwhelming. But if I ask an AI model to synthesize the last 12 months of human trials on GLP-1s for longevity outcomes, it can scan all of that input and hand me a comparative summary in plain language. What's promising, what's inconclusive, and where the research is too early. Here's something most people don't realize. Different AI models actually have different personalities, which are deliberate design choices when it comes to health information. I've noticed that Anthropic's Claude tends to be more conservative and cautious, often flagging limitations and risks more prominently, with OpenAI's GPT models tending to be more comprehensive, but sometimes overly optimistic. Google's Gemini excels at finding connections across different research domains, but can sometimes miss nuanced methodological issues. And this isn't a bug. It's a feature. When I'm researching something complex like senolytic compounds or NAD precursors, I want multiple perspectives. It's like having a panel of research assistants with different expertise and bias patterns. Now let's talk about model selection, because this is an area where AI has gotten a lot smarter. I break models into 3 tiers, and each one shines at a different type of question. Reasoning models are your deep thinkers. They're best for high-stakes, multi-step reasoning. This is what I use where I'm asking something like, design a 5-year preventative health plan using my family history, labs, and wearable data, or cross-analyze 3 different peptide studies to find patterns. These models take longer, but are incredible for connecting dots and spotting nuances. Flagship models are your workhorses. They excel at structured synthesis, summarizing complex studies, or turning a stack of PDFs into actionable insights. For example, I'll ask, summarize every human trial on spermidine supplementation, including endpoints, study sizes, and limitations. This is where I get clear evidence-based summaries. Lightweight models are your quick helpers. They're great for questions like, what is ApoB, or give me the RDA for magnesium by age group. They're lightning fast and perfect for quick fact checks or definitions when you don't need deep reasoning. Now here's the big shift as of this recording. GPT-5 of OpenAI, which is what you'll probably be using on ChatGPT, has automatic model routing built in. It silently decides which version of itself to use based on your request. If you ask a lightweight question, it responds almost instantaneously using a faster model. If you upload a 50-page study and ask for detailed analysis, it switches to its advanced reasoning model behind the scenes. And this makes research workflows faster and smoother because you don't have to choose the right model every time. And that said, I don't always let GPT-5 make the choice for me. When I'm dealing with something high stakes, like analyzing new trial data that could influence my health plan, I force model selection manually. I'll start with OpenAI's GPT-5 on ChatGPT in thinking mode for a slow, thorough pass, switch to a lightweight mode for quick fact checks, and then run the same question through Anthropic's Claude Sonnet or Google's Gemini Pro to compare perspectives. This manual switching gives me confidence because I know exactly which quote-unquote brain I'm talking to, and it makes cross-checking much easier. And when I do want convenience, I let GPT-5's auto-routing pick the fastest or deepest setting behind the scenes. Another feature I use constantly is deep research mode, which is an added feature for the flagship models. This is where the models don't rely on their training data, but actively fetch fresh sources from the web, summarize them, and provide citations. I'll often ask, what's been published this year on rapamycin in healthy adults, and get up-to-date references in minutes. And here's one more pro tip. The order in which you ask questions matters. If I start with, is NAD supplementation worth it? I tend to get a promotional leaning summary. But if I ask, summarize the current evidence on NAD supplementation, including studies that show no benefit, I get a more balanced response. This is called prompt sequencing. I always begin with neutral evidence-first prompts to get the lay of the land, and then move into specific recommendations or personal applications. Longevity is what can be classified as a wicked problem, a problem so complex that even defining it is hard. It's not a single question like, what supplement should I take? It's an intricate puzzle made up of genetics, molecular biology, nutrition, pharmacology, exercise, physiology, psychology, and even behavioral science. It's a moving target. New studies are published daily, experts' opinions shift constantly, and what seems groundbreaking one year might look outdated or incomplete in the next. Even specialists admit they can't keep up with the entire field. A top exercise scientist might not follow the nuances of mitochondrial pharmacology, and a nutrition researcher might not be tracking the developments in peptide therapeutics. So if you're someone trying to build a personal roadmap to better health and longevity, it's no wonder you might feel overwhelmed. This is exactly where AI shines. I see it solving this problem in 4 key ways. First, scanning the horizon quickly. Say a peptide trial gets published in Japan this morning. AI can summarize it in English today rather than having you wait until it is mentioned in Western journals or for someone to write about it. You can get early insights straight from the source. Second, AI helps synthesize across silos. Longevity research is notoriously fragmented. Nutrition studies live in their own journals, pharmacology trials focus narrowly on drug endpoints, and wearable device data isn't usually integrated into clinical literature. These fields rarely talk to each other, so you're often piecing together knowledge by hand. AI can bridge those divides by pulling from multiple disciplines at once, summarizing trends, and even translating field-specific jargon into plain English. To be clear, it's not discovering new causal relationships on its own, but it's like having an assistant who's read tens of thousands of papers across all of these domains and can put them side by side, making connections you might otherwise miss. Third, highlighting gaps and risks. One of the most underrated skills of a good AI workflow is its ability to point out what's missing. It's not just about answering your question, it's about saying, here's where the evidence is thin, here's what hasn't been studied, and here's what you should be cautious about. And lastly, personalizing your research. This is where it gets truly exciting and becomes your personal strategy assistant. You can feed in your own lab results, wearable data, goals, and lifestyle context, and AI will filter its synthesis through your personal lens. That's a huge leap from generic supplement advice. But here's the most underappreciated benefit of all. AI helps you uncover what you don't know about what you don't know. Take BPC 157. I started seeing it all over social media and started researching it for gut health and wanted dosing guidance. AI immediately flagged that peer-reviewed human evidence is extremely limited and that the first sanctioned human trial only started in 2025 and that the FDA has issued warnings about unapproved peptide products. That completely reframed my approach. Instead of obsessing over doses, I asked, is this even worth pursuing now? And that's the real magic. AI doesn't give you answers. It helps you ask better questions. It also keeps you current in a field where information ages fast. Take NMN versus NR as an example. In just a couple years, the conversation about their bioavailability, timing, and optimal dosing has shifted completely. If your plan is built on a blog post from 2022, you're already missing critical context. AI makes staying updated easier and far less cumbersome. Instead of drowning in journal alerts, you get an intelligent briefing system that surfaces the most relevant, actionable information for you. This is a practical piece and probably the most important. How to use AI responsibly for research. First, the golden rule. AI is a starting point, not an end point. If you remember one thing from this episode, let it be that. Here's my framework. First, I start broad and get the overview. I open with a flagship model like GPT-5 or Claude Sonnet and ask a question like, explain senolytics in plain English. What are they? How do they work? What's the current human evidence? And what are the key risks and unknowns? This gives me the lay of the land. GPT-5 is excellent for this foundational pass compared with earlier models, but I still treat the output as a draft to verify. Next, I go deeper with evidence-focused queries. I switch into the web-connected deep research mode and then ask questions like, summarize recent peer-reviewed human studies on senolytics prioritizing the last 24 months. Include study size, population, endpoints, duration, limitations, funding and disclosures, and provide links and DOIs. This prompts the model to fetch and cite rather than rely only on training data. I always click through to confirm that the papers exist and that the details match. Then I cross-check across models. I paste that summary into another model and ask, what's missing? Where might this be overstated or biased? What alternative interpretations should I consider? It's like having two colleagues peer review each other's work. Lastly, I extract actionable insights. Once I have a nuanced picture, I ask, based on this evidence and its limitations, what are 3 questions I should ask my doctor if I'm considering a senolytic approach? This keeps me grounded. The goal isn't DIY medical care. It's to show up to professional conversations better informed. Now let's set some ground rules for using AI in health research. These are guardrails that I highly recommend to anyone experimenting with AI tools because they'll save you time, reduce frustration, and most importantly, help keep you safe. First, always verify citations. Early in my longevity journey, I asked GPT-4 about a specific NAD study I thought I heard mentioned on a podcast. I gave it some parameters of what I remembered, and it gave me what looked like a perfect summary, with the sample size, the methodology, the results, and even the journal name. I was really impressed and almost started a protocol based on it. Fortunately, I double-checked. The study didn't exist. AI had fabricated everything, the journal name, the authors, and the findings based on what I had given it. It was so convincing that I almost fell for it completely. This phenomenon is what's called hallucination. In AI, a hallucination is when a model confidently gives you an answer that sounds correct but isn't based on real data. It's not lying, it's predicting text based on patterns in its training, even when those patterns don't line up with reality. Now I have a rule. Every citation gets verified. I click through to PubMed, check the actual paper, and confirm that the details match. That extra 5 minutes has saved me from more than one wild goose chase. Second, use multiple models. No single model has all the answers. Each has its own training data, architecture, and bias patterns. When models disagree, it's not a failure. It's a signal that you've hit a nuanced topic that's worth deeper investigation. Third, watch out for correlations without context. AI is excellent at spotting patterns, as we've mentioned before, but it doesn't know which ones are meaningful. Just because your wearable data shows improved sleep during a supplement trial doesn't mean that the supplement caused it. Always question correlations, look for confounding variables, and ask the model to identify alternative explanations. Fourth is the recency gap. Here's another hidden danger. AI models are trained on data that could be months or even years old. If you're making decisions based on outdated science, you're missing the full picture. Use research modes or web-connected tools to pull in studies from the past year, especially for fast-moving topics like longevity. And lastly, account for bias. Bias is everywhere. Scientific literature is shaped by funding, publication trends, and human bias, and AI reflects these same patterns. Ask your model directly, what's underrepresented here? Where might this research be skewed? This is one of the fastest ways to surface blind spots. And these 5 guardrails, verifying citations, using multiple models, questioning correlations, prioritizing recency, and accounting for bias, will help keep your AI-powered research grounded and safe. After experimenting with different AI models for longevity research, I've noticed that each have distinct personalities and strengths. Understanding this can dramatically improve your research efficiency. Do note that the research in the AI field is also fast-moving, so by the time you hear this recording, some of the model names and strengths could have changed. GPT-5 is my go-to for broad literature reviews and complex synthesis tasks. It's strong at pulling together information across domains and presenting it in a structured table or summary. Compared to the earlier models, its reasoning has noticeably improved. It's gotten great at identifying methodological issues and study limitations, though it can still default to optimistic summaries if not prompted carefully. I use GPT-5 when I want a complete landscape view, something like summarize everything known about spermidine supplementation, including mechanism, human studies, risks, and knowledge gaps. Claude is my skeptical partner. It's consistently more cautious about health claims and excels at pointing out study weaknesses, overstatements, and limitations. I often run Claude after GPT-5 and ask, where might this be overhyped? What are the key limitations here? Claude is especially good at flagging when a trial is too small or short-term to draw meaningful conclusions. Google's Gemini, especially Gemini Pro, is great for finding cross-domain relationships. It's my go-to when I want to explore combinations or interactions, something like, how might NAD supplementation interact with metformin? Or what's the link between circadian biology and senolytic timing? Perplexity isn't a model, but it is a tool that I use a lot for its real-time web search. I use it to check for new studies, trial updates, or safety alerts. Something like, what's been published in the last 3 months on rapamycin dosing strategies, or are there any new safety warnings about NMN? And here's how I usually work. I start with ChatGPT for a structured overview, run Claude for a skeptical critical pass, use Perplexity to verify sources and check for recent publications, and then go to Gemini for higher level connections and pattern spotting. This might feel like overkill, but for important health decisions, an extra 10 minutes of cross-checking has saved me from countless poor choices. In longevity research, nuance is everything, and this rotation keeps me grounded. The difference between good and great AI research often comes down to how you ask the questions. Over time, I've developed a set of prompts that completely changed how I use these tools for longevity research. I'll add these in the show notes so that you can always come back and refer to them. First is the evidence hierarchy prompt. Instead of asking, does X work? I ask, summarize the evidence for X across different study types: animal studies, observational human studies, small RCTs, and large RCTs. Rate the strength of evidence for each level. This pushes the AI to categorize studies and gives me a clear picture of where evidence is strong, weak, or purely speculative. Next is the limitation-first approach. Rather than starting with benefits, I lead with what are the limitations, methodological issues, and knowledge gaps in the research on X. This primes the model to be critical and often reveals weaknesses I might not think to ask about on my own. Generic advice is often useless. I recommend to provide context, something like, I'm a healthy 55-year-old male, normal BMI, high blood pressure, and interested in longevity optimization. Given this context, how should I interpret the research on X? The model won't give medical advice, but it will filter studies that aren't relevant to your demographic or goals. The timeline template I use for supplements or interventions. I'll ask something like, create a timeline showing when effects typically appear, when they plateau, when tolerance might develop, and if breaks or cycling might be beneficial. This helps set realistic expectations and plan long-term protocols. The interaction matrix I use when I'm considering multiple interventions. Something like, create a matrix showing potential interactions, synergies, and conflicts between X, Y, and Z. Include timing considerations. This is great for stacking and sequencing interventions, but again, I always cross-check these suggestions with clinicians. I'll use the update request to make sure that I stay current. I'll ask something like, I last researched X in June of 2025. What new studies or safety updates have emerged since then? This saves time and ensures I'm not relying on outdated science. And these prompts don't give me the final answers, but they do give me structure. They make AI a better research assistant, help me surface gaps in the evidence, and help me keep me up to date without going into information overload. I also want to share how I integrate AI with traditional research methods. Early this year, I was curious about spermidine, a compound getting buzz as a potential autophagy enhancer. Instead of skimming random websites, I went to GPT-4o and asked, summarize the evidence for spermidine supplementation in humans, focusing on longevity and cognitive outcomes. It produced a solid overview, observational data linking higher dietary spermidine with reduced all-cause mortality, plus small interventional studies suggesting memory improvements. Then I ran the same notes through Claude and asked, where might this be overhyped? Claude flagged two things. First, that most strong evidence comes from observational studies, so correlation, not causation, and that human RCTs are still small and often underpowered. That context shaped my perspective. Instead of rushing to add spermidine capsules, I noted this as emerging, promising, but unproven, something that is worth watching, but not yet a cornerstone in my routine yet. And that's the power of using AI. It helps you avoid hype traps while staying open to possibility. AI is not a replacement for deep critical reading. For me, I use the 80-20 rule. I use AI for the initial 80% of research to help me get oriented to understand the landscape and identify key studies and researchers. But for the final 20%, the studies that actually influence my decisions, I read the full papers myself. And that's where you can catch subtle methodological issues, conflicts of interest, or limitations buried in the method sections that can completely change your interpretation. And AI has helped me build a curated library of landmark studies in longevity. I'll prompt, what are the 10 most important studies in this field that I should read in full? Over time, this has built a knowledge base that no AI summary can replace, and it makes me better at spotting gaps or exaggerations in future AI outputs. And this is a little bit of a repeat, but whenever AI cites a study, I run a quick verification process. I make sure that the studies exist, that the details are accurate, and that what the authors actually conclude matches what the model says that they conclude. This habit has caught numerous errors and subtle misinterpretations that could have led me astray. By blending AI speed with the rigor of traditional research, I get the best of both worlds. AI gives me breadth, helping me cover more ground than ever before, but depth, the careful reading, the critical analysis, and the conversations with professionals still come from me. And this is how I make AI a powerful assistant instead of a replacement for real scientific thinking. Let me ground this all with one more detailed example that shows this entire process in action and how it ultimately led me to add a supplement to my own stack. I became curious about Urolithin A, a metabolite produced by gut bacteria from pomegranate compounds that's been generating buzz as a mitochondrial enhancer. I first started with GPT-5 and asked, explain Urolithin A, what it is, how it's produced, proposed mechanisms for longevity, and current evidence quality. This gave me a clear baseline. Urolithin A supports mitochondrial health, requires specific gut bacteria to produce naturally, and most people can't synthesize enough without supplementation. Then I asked Claude, what are the limitations and potential issues with Urolithin A research and supplementation? Claude flagged some limitations, that many studies are still in cell or animal models, human studies are small and often funded by the supplement company, and that natural production varies widely depending on gut microbiome diversity. And to make sure I wasn't missing anything, I used Perplexity to ask what new research on Urolithin A has been published in the last 6 months. It surfaced 2 new small human trials, plus emerging questions about optimal dosing that hadn't been widely discussed yet. Then I framed the question in the context of my own health stack. Given that I'm healthy, have a diverse microbiome based on recent testing, and already take mitochondrial support supplements, how should I prioritize Urolithin A? The AI suggested that I started by testing my baseline Urolithin A levels given my diet, and use supplementation if levels still remained low. It essentially positioned it as a strategic add-on rather than an urgent must-have. Finally, I pulled and read 3 key human studies myself. The AI summaries were mostly accurate, but I noticed some additional nuances. Things like individual response varied widely, and that the supplement appeared overall safe. In the past, I might have skipped straight to purchasing a bottle based on the marketing hype. This time, after 2 hours of AI-assisted research and direct study review, I took a more measured approach. I tested my baseline, improved my polyphenol intake through food, and then added Urolithin A supplementation to my stack. I also made sure to track biomarkers and subjective outcomes along the way. And what I love about this process is that it didn't help me decide yes or no. It made me confident in why I'm taking Urolithin A, how to monitor its effects, and how to adjust in the future. So wrapping up our episode, here are some key takeaways. AI isn't magic, but it is a pattern machine that makes you dramatically more efficient at navigating complex science. Different models have different strengths. Use them strategically rather than defaulting to just one. AI matters for longevity because the field is too big, fast-moving, and interdisciplinary for anyone to track alone. The responsible way to apply AI is as a filter, a synthesizer, and a sparring partner, never as a final authority. And lastly, cross-model verification and traditional research methods are still essential for important decisions. Done well, this workflow saves time, sharpens questions, helps you avoid hype traps, and allow you to walk into your doctor's office with stronger foundations. And honestly, it makes the whole process more fun and intellectually engaging. Next episode, we're going deeper into the practical implementation side, how to set up your own longevity AI agent, upload your data from wearables and labs, and build a system that helps you track and adjust protocols over time. We'll talk about turning those fuzzy, I feel better moments into quantifiable data you can actually learn from, and I'll walk you through the technical setup process step by step. Until then, remember, AI is here to empower your curiosity, not replace your judgment. When used with a clear process, skeptical eye, and a sense of intellectual rigor, it becomes one of your most powerful longevity tools. Thank you for spending your time with me today on Adding Years, your roadmap to longevity. If you found this episode helpful, please follow or subscribe on your favorite podcast platform and consider leaving a review. Before we wrap up, a quick but important reminder. Adding Years is for informational and educational purposes only and is not a substitute for professional medical advice, diagnoses, or treatment. Always consult your physician or qualified healthcare provider before making changes to your health regimen, supplements, or exercise routine. What you hear on this show reflects personal opinions, experiences, and not medical advice. I'm Josie, and this is Adding Years. Until next time, here's to living better, longer.